Let's do a problem about polynomial functions. Okay, here this problem is taken from book, and it asks us to find the intercepts and end behavior of a polynomial function, which is given in this way. First of all, let us find the end behavior of this function. Okay, so this is certainly a polynomial function since there is no quotient form and neither we have imaginary expressions. Okay, so this is quotient form. So this is a polynomial. Okay, first let's go for end behavior. First let us find the degree. Okay, degree of the polynomial f of x. To find the degree of this polynomial, let us calculate the individual powers of each x. So let us find the individual power of x. Okay, this x has power 1. This x also has power 1. So this x also has power 1, but it is squared. Now if you expand this factor, then you will be getting 4x square. Okay, positive 4x square minus 2 times x times 2 times x times 10. Okay, so that would be 2. Okay, power of this x is 2, so that's why we have 4. Okay, so the degree of this polynomial is 4th degree. Okay, degree is 4. Now let us find out whether a is positive or not. Okay, a means the leading coefficient. The coefficient of this x is positive times, in this factor the leading coefficient or the coefficient of x is -2, so that would be negative in this case. And here if you expand this binomial factor, then it will give us 4x square. You can simply see that that's negative whole square. That will give us plus times minus times plus, which is minus. Okay, so therefore we can say that a is less than 0. Since the polynomial is of even degree and it is negative and the leading coefficient is negative, so our polynomial would be, the end behavior of our polynomial would be, that means as x goes to either positive infinity or negative infinity, y goes to negative infinity, since the leading coefficient is negative. So that's the end behavior of the function. First of all, let's go for y-intercept. For y-intercept, we set x equals to 0 in this function. Okay, so this is y equals to f of x. So if we set x equals to 0, then y equals to f of x becomes, this is 0 times 14 minus 2x, that's 14 minus 0, and this is certainly 10 minus 0 whole square. So this is simply 0. Okay, so you can see that 0, 0 is the point where the curve meets the y-axis. Okay, now let us find out x-intercepts. To find x-intercepts, we set y equals to 0. Okay, then after setting y equals to 0, then our function becomes this: 0 equals to x times 14 minus 2x times 10 minus 2x whole square. Okay, since these all are linear factors, so we can equate all of them to 0 individually. So x equals to 0 would be the first one. Second one would be 14 minus 2x equals to 0, and the third one would be 10 minus 2x whole square equals to 0. Okay, first one we're good, we have already figured out the value of x, that is 0. Okay. Second one, you can just solve this equation and find out the value to be x equals to 7. 10 minus 2x to the power 2 equals to 0 means this factor is repeated for 2 times. Okay, so let us just find out the value one time, and then we can realize that this value occurs twice. So that is 10 minus 2x equals to 0. Then after solving this, you can see that 10 divided by 2 is 5, so x equals to 5. So the x-intercepts are 0, 7 and 5. Okay, and 5 is repeated for 2 times. Okay, so these three are x-intercepts. Then if you want to locate the x-intercepts and y-intercepts, then this might be a tentative way to do it. So this is x equals 0, where both x and y-intercepts lie. This is 5, and this is, let's suppose, 7. This might be the curve. And degree is 4 means we have at most 3 turning points. Okay, so this might be one turning point. This might be second turning point, and it passes through this thing. Okay, so this might be a tentative curve.